All right, we're going to do a little probability. So when we do probability, there's what's called theoretical probability and experimental probability. Theoretical probability is when we don't do an experiment and we just say, in theory, your probability would be this. Experimental probability is when we actually experiment, like flipping a coin over and over again, to see if our probability makes sense, okay? But probability of any event, so the probability of event is always going to be equal to the favorable outcome that you want over the total outcomes. Always, okay? So keep that in mind. You always want to simplify it. I only need a fraction. You don't need to turn it into a percent. There's a very important chart on page 311 that goes over when you roll two cubes. What kind of outcomes do you get? So let me show you. This is a really important chart right there that you need to keep in mind, okay? So here we go. So a number cube is rolled, which is the same thing as a dice. They just don't want to call it that. Always assume it's a fair dice and that it's a 1 through 6 dice unless said otherwise. What is the probability of rolling a 4 or a 5? Well, the probability of rolling a 4 or 5, well, there's two numbers on the cube, that's a 4 or a 5, see? And there's 6 total outcomes. So favorable is 2 out of total outcomes, 6 or 1/3. You don't have to give me the percentage, just give me the fraction. Cubist roll with the probability of rolling a number that's divisible by 3. So think about your numbers. 4, 5, 6. 3 is divisible by 3 and 6 is divisible by 3. So again, 2 out of 6, 1/3. Suppose 2 number cubes are rolled. So here's your chart that I said is on page 311, okay? Find the probability of rolling 2 identical numbers. First, I ask you how many total are on here if it's a 6 by 6 chart. 36, right? So remember, it's total outcomes on the problem, on the denominator, sorry. The probability of this event is equal to, well, how many doubles are there? Right here. There's always a pattern, look for it. 6 out of 36, 1 6. That's it. 2 numbers are cubed. Find the probability of rolling 2 numbers whose sum is 8. So let's go back to the chart. So we're looking for a sum of 8. That means when I add the 2 numbers together, I get 8. So do you see that it's right here? So how many times do you see that? 5 out of 36. So the probability that you get a sum of 8 is 5 out of 36. Okay. All right, those were theoretical probability. This is experimental probability. So what's the probability that you're landing on heads? There's 14 out of the total experiments that you did, 25. Now remember, the probability that you land on a heads or tail is half, right? This is experimental, so we have to look at our experiment. We would like to know that this percentage would be about a half, 50%. It's pretty close. Brian is shooting baskets with a basketball. He makes 13 shots and misses 9 shots. So the probability that he makes the shot is he made 13 out of a total of 22 shots. So remember, this is favorable over total. So you needed to put these 2 numbers together to find your denominator. Miss Newman surveyed her class to see which sport they preferred watching. How many would you expect to say they preferred watching basketball? Well, there are 560 students in the class, and 28% of them said they liked basketball. So you're just going back to the part equals percent times base. Or you can set up the proportion like that. So you can say about 157 students. This one, how many would you expect to say they liked red? So let's set it up like a proportion if they prefer. 29 said red over 100. Your base is a total of 450 students. You're looking for the part. Cross, multiply, and divide. So you can expect 131 students. And that's probability. And the end of chapter 6. Good luck.